In this video, I'm going to show you how to find the center and radius of a circle written in general form. But first of all, before we do that, let's just practice finding the general form for a circle. So if we're given this equation, quantity x minus 1 squared plus quantity y plus 2 squared, and that equals 9, and this equation represents a circle with center 1, negative 2, and radius root 9, which is 3, we want to rewrite this equation in general form x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are just coefficients. So this is really just asking us to expand out our equation. Let's expand out these squared terms and get our x squared, y squared, x, y, and f, the constant, set that equal to 0. So let's just write out our equation here. So x minus 1 squared plus y plus 2 squared equals 9. And let's expand out each of these terms. So x minus 1 squared, well, that's just the first term squared, x squared, and then plus 2 times the first term, plus 2 times x times the second term, times negative 1, and then plus the second term, negative 1 squared. Okay, and then y plus 2 squared, why don't we put these in brackets to separate them? So then y plus 2 squared is again just the first term squared. So y squared, then plus 2 times the first term times y times the second term, so times 2, and then plus the second term squared, so plus 2 squared. And that's equal to 9. Okay, so let's compute this and write it out. So this is x squared plus actually, this is x squared, then minus 2x, and then plus 1, negative 1 squared is 1, and then plus y squared plus 4y plus 4. And that's equal to 9. Let's group this up. There's an x squared and a y squared, so let's write that in front. X squared plus y squared, that way it matches the general form that we're trying to get it into, x squared plus y squared. And let's put the dx term next, so minus 2x, and then next comes the ey. So that's the 4y here, so plus 4y, and then plus f, 1 plus 4 is 5, and that's equal to 9. Okay, so the only difference is that this has 9 on the right hand side. The general form is supposed to have 0 on the right hand side, so let's just subtract 9 from both sides, and the result then is that we just have x squared plus y squared minus 2x plus 4y, and 5 minus 9 is negative 4. That's equal to 0. So here we go. Here is our general form of that circle. Okay, so now that we've seen how to convert into general form, let's see how to convert out of general form. So given this equation, x squared plus y squared minus 4x plus 6y minus 12 equals 0, and that represents a circle in general form. And we want to determine the center and the radius of the circle. So that's the issue with general form. We don't know how to determine the center and the radius just by looking at the equation. We really have to rearrange it a bit. So what we really want to do is we want to rearrange this general form equation to take the standard form, x minus h squared plus y minus k squared equals r squared. Because that way we can tell that the center is just hk and the radius is r. So let's do that. So okay, so first step, let's just group up all the x terms together and all the y terms together and move the constant to the other side. So taking this equation, let's group up all the x terms together. We've got an x squared here and a minus 4x. So let's write that down. So x squared and then minus 4x, and let's also group up the y squared and the plus 6y, y squared and plus 6y. I'm going to leave a little bit of space and you'll see why in a second. So plus y squared and then plus 6y, and then that is going to equal, well, let's move this minus 12 to the other side, so add 12 to both sides, and that equals 12. Okay, So now you'll see the reason why I'm leaving space is because we'd like to turn each of these, this x stuff and this y stuff, we'd like to turn those into perfect squares. And do we know any methods by which to do that? Well, yeah, we can just complete the square. So remember, completing the square just involves adding something to both sides of the equation. So we'll add something for the x, and we'll have to add that to the 12 also, so plus that something. And then we'll also add something for y, and we'll have to add that to the other side as well. Okay, so let's do that. So here we got x squared minus 4x plus something. What do we need to add to turn this into a perfect square? Well, remember, we just have to look at the x coefficient here. X coefficient is -4. We have to divide that by 2 and square it. So -4 divided by 2, let's write that down, -4 over 2, and then square it. So that's just -2 squared, which is just 4. So 4 is what we're going to add here. So put that on the other side also. And now for y, it's the same idea. So take the y coefficient, which is 6, and divide it by 2 and square it. 6 divided by 2 squared is just 3 squared, which is just 9. So 9 is going to be the number that we add for y. Okay, so now let's write this down again. So x squared minus 4x plus 4, that can be factored into a perfect square. The perfect square is just x minus 2 squared. Remember, you can tell the minus 2 because it's just that coefficient divided by 2. That coefficient divided by 2 is just minus 2. That goes inside the square. Okay, and now the next one is plus our y terms. That goes into a perfect square also. So it's y, and then this middle term divided by 2 is 3. So y plus 3, let's just check to make sure. 3 squared is 9. Yeah, great. So y plus 3 squared is this y group here. And now on the right hand side, we just have 12 plus 4 plus 9. And 12 plus 4 is 16, then plus 9 is 25. Okay, great. So let's write this one more time. The only thing that we want to change here is we want radius squared on this side. Right now this is 25. So let's write this as a number squared. So this is x minus 2 squared plus y plus 3 squared is equal to, what squared is 25? Well, just think square root of 25. Square root of 25 is 5. So 5 squared is 25. So now we can see that the center is just, this is x minus 2, so center is 2 is h here, x minus h, center h. So center has an x coordinate of 2, and then a y coordinate. Be careful here, this is plus 3. And according to our formula, the center has the y coordinate y minus the y coordinate of the center. So why don't we write this as y minus -3 squared. And now we can see that the center y coordinate is just -3. Okay, and then what is the radius? Well, the radius is just this number, the thing that is being squared on the right hand side. So radius is just 5. So great, we're done. These are our final answers. And just to recap, all you really have to do to convert from general form to the standard form is just to complete the square on both of the x and y terms. But after you do that, when you're trying to find the center and radius, there are two things to watch out for. First of all, at the center, if there's a square that's like y plus something or x plus something, you always have to flip the sign of the number that comes afterward. If it's plus 3, that goes to -3 for the center, because standard form has the center in the form y minus something and x minus something. So if it's positive, you got to flip the sign. Okay, and then the radius, don't forget to take the square root of the right hand side. So we wrote this as 5 squared, so it was easy to see that the radius was 5. But if you just left it as 25, don't just write down that the radius is 25. You always have to take the square root of that right hand side, which is 5. Great, so now we know how to convert circles back and forth between general form and standard form, which is especially useful when we want to find the center and radius of a circle that's written in general form. In the future, we'll continue to do some more practice with circles, such as finding x and y intercepts.